Have you ever just dreamed of having a complete, self-sustaining food system right in your own backyard? You know, something that gives you fresh food all year round, no matter what the weather is doing? Well, today, we're going to dive into a design that promises exactly that. And we'll see how one team of innovators took this super high-tech concept and actually brought it to life. It all starts with a vision, right? I mean, just look at this thing. This is way more than a garden. It's a sleek, modular ecosystem. This is the dream, a compact unit that's designed to pump out all sorts of fresh food right at home all year long. It looks clean, it's efficient, and frankly, it's beautiful. But the big question is, how does it actually work?
All right, let's break this concept down. The goal here isn't just about growing a few extra vegetables. No, it's about creating a complete system for food independence, where every single part supports all the others in this continuous, self-sustaining loop.
So what can you actually grow in a system like this? We're not just talking about plants. This design integrates fish, leafy greens, and believe it or not, even mushrooms. And the absolute key here is that they all exist in what's called a symbiotic cycle. That just means the waste from one thing becomes food for another. They're all designed to help each other thrive.
Okay, so let's get into the mechanics of this aquaponic ecosystem. This is where the design gets really brilliant because it's just using nature's own processes to create this perfect, self-sustaining loop. Now, what's so cool about this view is how it lays out the whole system for us. Right there in the center, you've got the fish pond. The fish do what fish do. They produce waste, which is super rich in ammonia. Now, that ammonia can be toxic to them, but, and here's the genius part, that water gets pumped over to the plants. In there, beneficial bacteria act like these tiny little converters, turning that waste into nitrates, which is literally the perfect natural fertilizer for the plants. The plants then soak up all those nutrients, which cleans the water, before it goes right back to the fish. It's a perfect closed-loop system where absolutely nothing is wasted.
You really have to think of the fish as the engine of this entire operation. They're basically a living, breathing, natural fertilizer factory, constantly producing the nutrients needed to feed the entire ecosystem. And this is where all that amazing fertilizer goes to work. These planters for leafy greens take that nutrient-rich water and just turn it into a harvest. No soil needed, no chemical fertilizers, nothing like that. It is an incredibly efficient way to grow food. And this right here, this is where the design goes to the next level. The system even incorporates mushrooms by thinking about the air itself. See, just like we breathe out carbon dioxide, so do the fish and the plants. And guess what loves CO2? Mushrooms. It's just another layer of symbiosis, where every single piece is designed to work together. It's fantastic. So this all looks amazing as a high-tech concept, right? It's clean, it's modular, it's efficient, but that raises the really big question. How do you take an idea like this off a computer screen and actually put it into your own backyard? And this is where our story takes a really cool turn, because one team of inventors didn't just design this concept, they actually figured out how to build a real-world version of it, using accessible, everyday materials to bring this whole dream home. And here you have it. On the left, you see that polished concept, the dream. And on the right, that's the real thing. It might not have the same sleek finish, but it's a tangible, working version of that dream, built in somebody's backyard. So let's take a look at how they did it. Okay, so to make this ecosystem work all year, especially if you live in a colder climate, it needs to be protected from the elements. So the practical solution starts with building a pretty specialized greenhouse to house the entire system. All right, so let's get into the blueprint and see how this was actually built. We're going to walk through the key steps of putting together what's known as a passive solar greenhouse. So the whole build really boils down to 4 key stages. First, you got to find the perfect spot to capture the sun's energy. Second, you put up a basic frame. Third, you modify that frame for its unique purpose. And finally, you install the critical life support system for the fish. Step 1 is all about location. And honestly, this is just plain smart. Passive solar design just means using the sun's natural path to your advantage. As you can see from this little sun chart, the greenhouse is positioned to catch as much of that low-hanging winter sun as possible, which naturally heats the whole structure during the coldest months. Now, you might be thinking, a structure like this requires all sorts of expensive, custom parts. But the source material reveals the secret to making this so accessible. Just like the quote says, the foundation of this entire build is a standard, off-the-shelf 10 by 20 foot carport kit. How clever is that? And here you can see that core structure going up. It's such a simple, accessible starting point that makes a project like this feel so much more achievable for, an average person. This is the skeleton of the entire future food ecosystem.
So to create that slanted roof you need for the passive solar to work, the basic carport frame is then extended. And again, this is done using simple, affordable materials you can find at any hardware store, just PVC tubing and couplers. It's a really clever, low-cost modification that completely changes how the structure works.
Okay, this is a really crucial point. System stability. What happens in the winter if your plants die back or just aren't growing as fast? Well, that means they aren't filtering the water. And that's where this hard filter comes in. It's a dedicated mechanical and biological filter, basically a permanent home for all those waste-converting bacteria we talked about. It keeps the water healthy for the fish, totally independent of the plants. It's like an insurance policy.
And here it is, that hard filter in action. It's the life support system, the unsung hero, making sure the fish, the engine of the whole operation, stay alive and healthy all year round. This makes the entire system so much more resilient and reliable.
And here it is, the finished product. Covered in snow, but inside, that ecosystem is protected and it's functional. This is the proof, right here. It shows that with smart design and accessible materials, you can create a productive, food-growing environment that can totally withstand the elements.
So we've gone from a slick digital concept to a rugged, real-world build. Let's just wrap up by talking about what this really means and, why this stuff matters. The most powerful takeaway from this whole thing is empowerment. It proves that these cutting-edge ideas for sustainable living and food independence, they aren't just for research labs or giant corporations. They can be understood, they can be adapted, and they can be built by passionate individuals using materials you can find in your own community. This team saw a vision for a better way to grow food, and they brought it to life with their own ingenuity and with accessible parts. It proves that an idea can become a real source of year-round food. So it really just leaves us with one final thought. What problem will you solve? What concept will you make real?